Hello everybody. Today we are going to see system design and modeling. Let's read this chapter and see what we get to know today. Let's straight jump to the introduction as we always do without wasting time. System introduction. System design is the specification or construction of a technical computer based solution for the business requirements identified in system analysis phase. During design, system analysts convert the description of the recommended alternative solution into logical and then physical system specifications. She or he must design all aspects of the system from input and output screens to reports, databases, and computer processes. Databases are designed with the help of data modeling tools. For example, ER diagrams and computer processes are designed with the help of structured English notation, decision trees, and decision tables. Logical design is not tied to any specific hardware and software platform. The idea is to make sure that the system functions are intended. Logical design concentrates on the business aspects of the system. In physical design, logical design is converted to physical or technical specifications. During physical design, the analyst team takes decisions regarding the programming language, database management system, hardware platform, operating system, and networking environment to be used. At this stage, any new hardware or software can also be purchased. The final output of design phase is the system specifications in a form ready to be turned over to programmers and other system builders for construction coding. Objectives. After going through this unit, you should be able to design major components of the system, identify tools for every component, to learn the process of using tools and integrate components designs into a whole system specification. Logical and physical design. Logical design is the phase of system development life cycle in which system analysts and user develops concrete understanding of the operation of the system. Figure 7.1 depicts various steps involved in the logical design. It includes the following steps: designing forms, hard copy and computer displays, and reports, which describe how data will appear to users in system inputs and outputs. Designing interfaces and dialogues, which describe the pattern of interaction between users and software, and designing logical databases, which describe a standard structure for the database of a system that is easy to implement in a variety of database technologies. Design forms and reports, design interfaces and dialogues. Here you can see the diagram and just see how the diagram is. Steps in logical design, and we will straight move to in logical design. All functional features of the system chosen for development in analysis are described independently of any computer platform. Logical design is tightly linked to previous system development phases, especially analysis. The three subphases mentioned in the figure 7.1 are not necessarily sequential. The project dictionary or case repository becomes an active and evolving component of system development management during logical design. The complete logical design must ensure that each logical design element is consistent with others and satisfactory to the end user. Form design. System inputs are designed through forms. The general principles for input design are: capture only variable data, do not capture data that can be calculated or stored in computer programs. Use codes for appropriate attributes. Include instructions for completing the form. Data to enter should be sequenced. Common GUI controls for inputs. Text box. It can allow for single or multiple lines of characters to be entered. Radio button. Radio buttons provide the user with an easy way to quickly identify and select a particular value from a value set. A radio button consists of a small circle and an associated textual description. Those responses to the value choice. Radio buttons normally appear in groups as one radio buttons per value choice. Checkbox. It consists of a square box followed by a textual description of the input field for which the user is to provide the yes or no value. List box. A list box is the control that requires the user to select a data item's value from the list of possible choices. It is rectangular and contains one or more rows of possible data values. The values may appear as either a textual description or graphical representation. Drop down list. It is like a list box but is intended to suggest the existence of hidden list of possible values for a data item. Combination box. It is also known as combo box. It combines the capabilities of a text box and list box. A combo box gives the user the flexibility of entering a data item's value or selecting its value from a list. Spin box. A spin box is used to allow the user to make an input selection by using the buttons to navigate through a small set of meaningful choices. The following steps are to be followed during the process of input design are given below. Identify system inputs and review logical requirements. Select appropriate GUI graphical user interface controls. Design, validate, and test inputs using some combination of layout tools, example hand sketches, printer/display layout chart, or case. Prototyping tools as example spreadsheet, PCDBMS, 4GL. If necessary, design the source document. Reports design. System outputs are designed through reports. Outputs can be classified according to two characteristics: their distribution inside or outside the organization, and the people who read and use them, and their implementation method. Types of outputs. Internal outputs. Internal outputs are intended for the owners of the system and users within the organization. There are three subclasses of internal outputs: detailed reports, present information with little or no filtering or restrictions. Summary reports categorize information for managers who do not want to go through details, and exception reports filter data before it is presented to the manager as information. Number 2, internal outputs. These are intended for customers, suppliers, partners, and regulatory agencies. They usually conclude or report on business transactions. Examples of external outputs are invoices, account statements, paychecks, course schedules, telephone bills, etc. Implementation methods for outputs. The following are commonly used output formats. Tabular output, it presents information as rows and columns of text and numbers. Zoned output, it places text and numbers into designated areas or boxes of a form or screen. Screen output, it is the online display of information on a visual display device such as CRT terminal or PC monitor. Graphic output, it is the use of a picture to convey information in ways that demonstrate trends and relationships not easily seen in tabular output. The following are various guidelines for output design. Computer output should be simple to read and interpret. The timing of computer outputs is important. The distribution of or access to computer outputs must be sufficient to assist all relevant system users. The computer outputs must be acceptable to the system users who will receive them. The steps to be followed during process of output design are given below. Identify system outputs and review logical requirements. Specify physical output requirements as necessary design and pre-printed external forms. Design, validate and test outputs using some combination of layout tools, example hand sketches, printer slash display layout chart or case. Prototyping tools, example spreadsheet, PC, DBMS, 4GL. Code generating tools, example report writer. User interface design. And mm, this chapter is a bit lengthy. User interface design. User interface design is concerned with the dialogue between a user and the computer. It is concerned with everything from starting the system or logging into the system to the eventually presentation of desired inputs and outputs. The overall flow of screens and messages is called a dialogue. The following are various guidelines for user interface design. The system user should always be aware of what to do next. The screen should be formatted so that various types of information, instructions, and messages always appear in the same general display area. Messages, instructions, or information should be displayed long enough to allow the system user to read them. Use display attributes sparingly. Default values for fields and answers to be entered by the user should be specified. A user should not be allowed to proceed without correcting an error. The system user should never get an operating system message of fatal error. If the user does something that could be uh, catastrophic, the keyboard should be locked to prevent any further input, and an instruction to call the analyst or technical support should be displayed. Logical database design. Data modeling is used for logical database design. A conceptual model of data used in an application is obtained by using an entity relationship model (ER model). ER model assists in designing relational databases. A relational database consists of a collection of relations relevant for a specified application. A relation is a table which depicts an entity set. Each column in the relation corresponds to an attribute of the entity. Each row contains a member of the entity set. Normalization is a procedure used to transform a set of relations into another set which has some desirable properties. Normalization ensures that data in the database are not unnecessarily duplicated. It also ensures that addition and deletion of entity rows or tuples or change of individual attribute values do not lead to accidental loss of data or errors in database. The steps to be followed during physical design are given below. Designing physical files and databases describes how data will be stored and accessed in secondary computer memory and how the quality of data will be ensured. Designing system and program structure describes the various programs and program modules that correspond to data flow diagrams and other documentation developed in earlier phases of life cycle. Designing distributed processing strategies describes how your system will make data and processing available to users on computer networks within the capabilities of existing computer networks. Depicts various steps involved in physical design. So this is the diagram you can see, and yes, steps in physical design. Then we will come to process modeling. Process modeling involves graphically representing the functions of processes which capture, manipulate, store, and distribute data between a system and its environment and between components within a system. A common form of a process model is data flow diagram. It represents the system overview. Data flow diagrams, a DFD, can be categorized in the following forms: context diagram, an overview of an organizational system that shows the system boundaries, external entities that interact with the system, and the major information flows between the entities and the system. In this diagram, a single process represents the whole system. First level DFD, a data flow diagram that represents a system's major processes. Data flows and data stores at a high level of detail. Functional decomposition diagram. Functional decomposition is an iterative process of breaking the description of a system down into finer and finer detail, which create a set of charts in which one process on a given chart is explained in greater detail on another chart. In this diagram, sub-processes of first level DFD are explained in detail. There is no limit on the number of levels of data flow diagrams that can be drawn. It depends on the project at hand. The following are various components of a data flow diagram process. During a process, the input data is acted upon by various instructions whose result is transformed data. The transformed data may be stored or distributed when modeling the data processing of a system. It doesn't matter whether the process is performed manually or by computer. People, procedures, or devices can be used as processes that use or produce means transform data. The notation given by Jordan for processes. What is this? Let's see. Only a circle. Data flow. Data moves in a specific direction from a point of origin to point of destination in the form of document, letter, telephone call, or virtually any other medium. The data flow is a packet of data. The notation given by Jordan for data flow is source of sink of data, the origin and slash or destination of data, sometimes referred to as external entities. These external entities may be people, programs, organizations, or other entities that interact with the system but are outside its boundary. The terms source and sink are interchangeable with origin and destination. The notation given by Jordan for source or sink is this: data store. A data store is data at rest, which may take the form of any different physical representations. They are referenced by a process in a system. The data store may reference computerized or non-computerized devices. Notation given by Jordan for data store is this: it is rules for drawing a data flow diagram. For process, no process can have only outputs, no process can have only inputs. A process is a verb phrase label for data store. Data cannot move directly from one data store to another data store. Data must be moved through a process. Data cannot move directly from an outside source to data source. Data must be moved through a process that receives data from the source and places it into the data store. Data cannot move directly to an outside sink from a data store. Data must be moved through a process. A data store has a noun phrase label for source slash link. Data cannot move directly from a source to a sink. It must be moved by a process. A source slash sink has a noun phrase label. For data flow, a data flow has only one direction of flow between symbols. It may flow in both directions between a process and a data store to show a read operation before an update. A data flow cannot go directly back to the same process it leaves. There must be at least one other process which handles the data flow flow produces some other data flow and returns the original data flow to the beginning process. A data flow to a data store means update, delete, or change. A data flow from a data store means retrieve or use. A data flow has a noun phrase label. So here we come to the end, and the answers of check your progress 1 will be available soon in the description. Okay, so thank you and keep exploring.